All right, everyone, welcome to today's presentation of DBA Fundamentals Group. Today we're talking about fabric databases and AI, everybody's favorite things to talk about these days, because we're going to start using vector search in fabric databases for AI. Today we have the great Dennis Torres to talk with us. As always, today is November 4th, if you're watching it on recording later. In the top right-hand corner of the screen, you should see all of the leaders of the DBA Fundamentals Virtual Group. Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you need to get hold of us, easiest way to get hold of us is on the right side of our names. Just ping us. We'll answer any questions you have. Below that, you'll see the easiest ways to get hold of us on social media. Top one there is Meetup, where most of you should have gotten the link for today's presentation. Need any if you connect with us on there, you can easily get to our presentations as they happen in the future because we always link them through there. Below that is our website, dbafund.com. You can actually see all of our past presentations. There's lots of links to them, over 12 years of presentations at this point, as well as our upcoming presentations. Below that is our favorite website, dbafundtube.com, where you can see all of our past presentations, as well as when you like and subscribe to our channel, you can actually get a notice when the latest recording is out there for you to view, so you'd be good to go at that point. Below that is our other ways of talking with you on X, Slack, and LinkedIn. Be sure to hit us up on all those. Some upcoming conferences. If you're in the Atlanta area, be sure to hit this one up. November 12th, it is the Apache Iceberg Community Meetup. It is, as you've probably started hearing some things about Iceberg, specifically Apache Iceberg here lately. This should be a great one to talk through. They're going to be having all kinds of conversations about it, learn more about it. And it's a great community meetup as well. That one should be fun if you're in the Atlanta area or can get to it here rather soon. Happens just next week. And then one of our favorite conferences that I'll actually be at next, actually in a couple of weeks here, the Past Data Community Summit is in Seattle, USA this year. We're going to actually have a good time with that. If you actually see me, please be sure to stop by and say hey. I actually have a presentation this year that I'll be speaking on. I'd be glad to talk with you at any time during the week. So it's all fun from there. Also, be sure to remember to turn off your video and mute yourself. If you have any questions, just put them into the chat and I'll be feeding them over to Dennis as time goes by. And so with that, speaking of Dennis, over to you.
Thank you very much, Kevin.
My pleasure.
Welcome, everyone. So today I'll be talking about Fabric Database and AI, specifically about vector search in Fabric Database. So I'll make an introduction about what are the Fabric Database, what's the relation between Fabric Database and other database solutions like Azure SQL, for example. Then we'll jump into what is vector search, how we use it in AI, and how is the implementation inside a relational database, specifically in Fabric databases. So this is me. I'm a former data platform MVP. You can see my contacts on the right side of the screen. It will be a pleasure to be in touch in social media like LinkedIn, YouTube. And if you would like to send me any questions, you can, no problem. I'm a trainer with some Microsoft certifications, and I'm the leader of the Malta Data Platform user group. I live in Malta. Yes. So let's talk about Fabric databases. Fabric databases are Azure SQL inside Fabric and with feature parity. The idea of telling that Fabric databases are Azure SQL inside Fabric, this highlights the fact that they have feature parity. So if Azure SQL releases a new feature, this new feature will be available in the Fabric database as well. So there is a feature parity between Azure SQL and Fabric database. In fact, the Fabric database are powered by Azure SQL. When we create a Fabric database, we are in fact provisioning an Azure SQL. So in Fabric, when you create a Fabric database, this is what we see. We see a link for the Fabric database itself appearing as a SQL database, and we see a link to the SQL Analytics endpoint. This is the node image. There is the full semantic model here, a feature from Fabric, but this feature is deprecated. So if it is still appearing in new provisionings, it will be disappear soon. The main point is the SQL database and the SQL Analytics endpoint. So this is what we see in Fabric. This is the image that we see when we provision this in Fabric. But what's the relation with Azure SQL? I said this is powered by Azure SQL and has feature parity and so on. What's the relation to Azure SQL? It's interesting to understand the internals of Fabric database because in this way we know better what is happening and the best way to use it. What is happening is that when we provision a Fabric database, we are actually provisioning an Azure SQL database. Behind the scenes, an Azure SQL database is being provisioned. And this Azure SQL database from Azure, what you see on the left side on Azure is the regular infrastructure of an Azure SQL database. There is nothing different from a regular Azure SQL infrastructure. So the Azure SQL is provisioned and the Azure SQL database is mirrored to Fabric. Is mirrored to Fabric to the one lake, to the Delta and Parquet files in one lake. So we have the actual Azure SQL and we have the mirror of the Azure SQL in Fabric. And the fact that we have both of them is very important for the architecture of the solution. So why should we use Fabric database? Well, no management trouble of cloud infrastructure. Even the easy to deploy Azure SQL, even it still requires us to know a bit about the Azure infrastructure. We need to deploy a server to include our database inside the server. There are many details about the infrastructure that we need to care about. In Fabric, we doesn't. We make the deploy, it provisions an Azure SQL behind the scenes, and we don't need to care about the details. So it's easier for what are called today nowadays as citizen developers. It's easier for citizen developers to work with Fabric database. This makes the Fabric database ideal for a low-code environment. For example, to be a database for a Power Apps application, to be a database for some work related to Power Environment, it makes it the ideal database for that. Besides that, there is a very good practice in the Fabric database that there is a pre-built isolation between production and analytics. Yes, this is a good practice that a lot of people forget to follow. That they should not put analytics workload over production. Analytics workload should not be put over production. So when we deploy a Fabric database, we have a pre-built isolation between the production and analytics. Let me see. There is one question here on the chat. Um, with the deprecation of the default semantic model for FabricDBs, will it be possible to make the modeling and analysis through a connection to the semantic model? Yes, the portal is becoming every day more powerful in relation to the capabilities to make semantic model editions directly in the portal, directly in powerbi.com. So yes, it will be completely possible. So what I was talking about the isolation between the production database and the analytical database. I also explained it before about the internal architecture that we have the Azure SQL and the mirrored database in Fabric. Yes, we have two. And the idea is that we'll use one for production and one for analytics. So we use the Azure SQL actually for production. And we put all the production workload over the Azure SQL, which is the SQL database. And when we are executing some analytical workload, we put our analytical workload over SQL Analytics endpoint. So the analytical workload can be put over the SQL Analytics endpoint. And in this way, this workload will affect the mirrored database, will reach the mirrored database, but will not affect the production workload. In this way, we have a natural isolation from production and analytics workload in Fabric database. And this good practice that is already implemented for us is great. We just need to pay attention and always connect to the right place. We need to connect to the SQL database if our intention is to connect to production. And we need to connect to the SQL Analytics endpoint if our intention is to make an analytical work. An interesting point in the relation between Azure SQL and Fabric Database is that Azure SQL only supports mirroring above S3. This tells us some details about the implementation of the Fabric Database. S3 is a SKU level in Azure SQL, which is not the basic one. It's not the basic one anymore. We have very small, very basic Azure SQL databases which can be provisioned by more or less $5 a month. You can provision an Azure SQL database by $5 a month, but not an S3. An S3, my guess is that it may be close to $200 a month. And considering this fact that only S3 support mirroring and the Fabric database depends on the mirroring architecture, the natural conclusion is that every time we provision a Fabric database, we are provisioning a database of size at least of an S3 in Fabric. This is only important for very small environments or very small solutions. If you think your solution could be smaller and could cost less than an S3, then maybe if this difference in cost is so important for you, maybe you would like to deploy directly in Azure SQL. Maybe. Uh, Okay, this is an interesting conclusion in relation to the features of Azure SQL. Let's take a look on how to connect to the Fabric database as if it is a regular database. I have here the SSMS, my SSMS environment, and it's interesting to use the Azure Servers window especially in this situation because the server name and the database name are not easy to remember. They are not easy to remember. You wouldn't like to keep all the time remembering the server name and database name to connect in Object Explorer. So it's better to create a registration and keep the registration to access your Fabric database. So let's take a look on my Fabric database. I have here the database called Vector Sample. Okay, with the SQL database and SQL Analytics endpoint. And you may notice that I can connect to either of them. For example, here I have the option Open in SSMS, for example. I use this option in the SQL Analytics endpoint. So it gives me the information related to the SQL Analytics endpoint. But if I use something similar, like the opening SSMS in the SQL database, the database name is slightly different, is not the same. Exactly because one is production and one is analytics. One is production and the other is analytics. Okay, in this case, I will use features which are very exclusive from Azure SQL. In this way, there is a parity with the production on the Fabric database, but not with the SQL Analytics endpoint. The analytics endpoint is reserved for analytical queries, like from transformations or from semantic models, for example. But if I want some parity with the features in Azure SQL, I need to connect to the production one. Uh, so I'll create a new server registration. I'll specify my server name and my connection will be using Microsoft Enter using MFA. Enter with MFA. Okay, let's specify my username, which is my login to the Power BI environment. The username is my login to the environment. And I'll copy the database name as well. It's very important to also include the database name because we have permission to connect to the database. Then on Registered Server, vector sample prod, the production of the vector sample database. Testing the connection. Test connection succeed. What happens is because my SSMS was already open, so it had my authentication in cache. What actually happens when you do this for the first time is that it will ask you your login to the Fabric environment. You need to log in with this account. Mine was in cache. Okay, let's open the connection. That's it. And I can see my database. Here is my vector sample database. And I have here two tables used in samples related to vector search. One is the Walmart product details. Another one is the Wikipedia articles and embeddings. Uh, In the example that I will illustrate in this session, we'll work with the Walmart product details. The point is how to find the right products for my needs. But I'm not talking about a simple SQL query. I'm asking and the database answering. I need to ask a question and the database needs to answer this question. Let's see what makes this possible. Let's talk about vector search and AI chat solutions. There is a solution which is called RAG architecture, retrieval augmented generation. The RAG architecture is very used usually for static documents, usually for documents like PDFs, docx, and so on. Static documents is not so common to have a RAG architecture related to a database. It's more used in static documents. But this RAG architecture establishes a very interesting standard, a very interesting pattern that is important for us. Is about how the RAG architecture retrieves the information for the user. The RAG architecture to retrieve information for the user, it uses a resource called embedding. What's an embedding? Embedding is a specific type of a vector. So these are two words that have the same meaning. However, vector is a word related to mathematics and is related to an element in mathematics and has a generic use. Embedding is a vector used for one specific purpose in our AI environment. The embedding is a vector used for natural language processing and for search of content to help us to search for a content. So vector and embedding in the context of AI, they are synonyms. Vector has additional meaning in relation to mathematics, in relation to other advanced features, but mostly in relation to AI context. When we're talking about embedding and vectors, we are talking about the same thing. So this is an embedding, and this is what actually makes it work. Of course, the chart is extremely simplified to explain the meaning of what is an embedding. The point is, for each word, we have the word transformed in a vector, and this vector is a numeric representation of the meaning of the word. So we see four words: queen, king, woman, man. Each word got a numeric representation of the meaning of this word. Then we can note uh, a comparison between the vectors. For example, queen and woman have the same first value in the vector. Why? Because a queen needs to be a woman. A woman is not exactly a queen, but a queen needs to be a woman. So the first value is the same. Man and king also have the first value the same because a king is a man. And the second value is different between all the four words because the meaning of the word is different. But we can note that the value between man and woman, the distance between this value is smaller than the distance between man and king. Man is closer to a woman than it's to a king. The same between woman and queen. The distance between a woman and a queen is bigger than the distance between a woman and a man. That's the point. We have a mathematical representation of the meaning of these words, and in this way, we can make mathematical calculations between this vector and calculate the distance. how close or how distant are the words to each other. And in this case, we are talking about search. Talking about search means that we have a content in the database and we have an input that we are searching for. The point is that the content in the database needs to have the embeddings created for it. We need to create the embeddings for the content in the database. Then, when an input comes for us to search about it, for example, I want to search about how to make a barbecue at home. What products do I need to make a barbecue at home? This sentence is the content that I would like to search. Then we can create the embedding for the sentence and we can look for the records that are closer in relation to meaning to my sentence. Then the search becomes a mathematical search and not a text search. And the level of precision that we get for this mathematical search is way better than a simple text search. Let's understand how this RAG, retrieval augmented generation, works on Azure. RAG is an architecture that we build on Azure using the Azure OpenAI service. We deploy on Azure OpenAI service. Then we have this service deployed on Azure, and the user makes a question through the OpenAI service. And the RAG is the architecture which allows the service to use the data from my company to answer the question. So how this architecture works? So inside Azure, we have the RAG, the Azure OpenAI service, which is this block. How this block is representing the Azure OpenAI service. The user makes a question. The question arrives through a coordination inside the service. A lot of people think that when the user asks something, this question arrives to the model itself, to the large language model. No, it doesn't. It arrives through a coordination inside the service. Then, this coordination inside the Azure OpenAI service create embeddings and vectors for the question. This means when the question arrives, we need to create the embeddings for the question. So this coordination goes to the embeddings model, a model deployed inside Azure OpenAI, and create the embeddings using this model. Create the embeddings for the question using this model. Then the Azure OpenAI use the embeddings to search for related documents. For this to happen, there is the need to already have a storage of the related documents. And there is the need to have the embeddings already created for these related documents. So, one common storage that is used for this architecture is called AI search, and it's a service provisioned on Azure. But the point is it doesn't need to be AI search. And with the advance of the vector search support in other resources like in Fabric Database and Azure SQL, the point is we can design solutions where this AI search step is replaced by a database. Yes, we can design that. That's the point. So, after the related documents were found inside the storage, then Azure OpenAI builds a prompt, a set of instructions to the model. And this prompt will include the information that was located in the storage. I'm calling this information documents, but it could be records from a database. The idea is to build the prompt including the located information. Then, after the prompt is built, the prompt is sent to the GPT model, the large language model, which will actually provide an answer. So, this prompt will include the original question made by the user and the information which is close related to the question. And that's what the large language model actually receives. It would be impossible for the large language model to analyze how the documents or how the records that we have. For example, imagine that a company has 1,000 documents, and this is very low considering most of the companies. Imagine 1,000 of documents. The model doesn't support analyzing all of them. So we need a powerful search engine which finds the information which is directly related to the question of the user and delivers the information closest to the question to the large language model. Then the Azure OpenAI receives the answer, the model, they receive the answer from the model and deliver the answer to the user. Let's see this and final step. So we made the search. The result of the search was returned to the coordination. The coordination builds the prompt, return the prompt give the prompt to the large language model, the GPT model, and then the answer is generated, and the answer is returned and displayed to the user. That's what happened in a RAG architecture. And we are talking about the possibility of replacing this AI search, which is the storage of the data, by a database. Yes, about the model. The model is this guy. So everyone thinks that when we are talking to to a chat, we are talking to a model. No, the model is inside the architecture, but we have all this process happening in a RAG architecture. Let's highlight some RAG limitations. When RAG was very fashioned, uh, and it is still important, although the fashion now is shifted to agents, but RAG is still critical and important to companies. So, but it's important to highlight some limitations. It's a document search and is limited by the prompt size. So the model itself is never analyzing all the documents. There is a search in the documents, either documents or records, to get what is closely related to the question. We will find the information, but it's like making a select with top 10. What is beyond top 10, we are ignoring. So there may be more information related to what the user is asking, and we are ignoring because it's not considered as close as the top 10. So it lacks database level precision. Exactly what I mean when I'm explaining this top 10. Uh, there may be a lot of information in the data source that is ignored by this architecture, is not retrieved by this architecture, because this architecture applies something which is similar to a top on the result. It's like this architecture is applying a top to the result. For example, if we make questions like, could you list the orders from customer XPTO? Could you list the sales from John? Could you list the bicycles orders? We have no way to be sure that a RAG architecture will deliver all the information needed for this question. We have no way to be sure about a database level precision. So RAG is more a knowledge management than an architecture that could deliver database level precision. RAG is not for database level precision. But we have now the capability to use vector search in relational database. And this brings a lot of possibilities. Vector search is part of the RAG architecture. We can use this as a different method to implement RAG, replace the I search in the RAG by a database, for example. Or it can be a workaround to reach results with more database precision answers. We can adjust the architecture to reach a higher database precision level answers. And this is a replacement for the simple text search. It's a way more advanced search method than a simple text search. We are talking about a natural language text search, a capability to make a question and receive an answer from the database. For example, uh, let's say that the question is, I'm looking to buy a comfy red sofa. So a text search results can return these results. But if you make a vector search by the similarity of the meaning, we may get additional results. Soft maroon coach, sleep time quiz on day bed. They have a similar meaning than what I'm asking, but they don't fit a text result. But if I'm using a vector search, these are returned because it's a search for the meaning. So, how the vector search actually works in the database? What are the main new features that we have in the database engine to support the vector search? We have a vector data type. This means that we can add one column in the tables that will be a vector type. This column will be of vector type and will be capable to store the embeddings. So we can create the embeddings and store in the table in the database. And we have a function called vector distance. It's not the only new function we have related to this, but is one of the most important, vector distance. This function allows us to calculate the vector distance between two values. We have two values and we calculate the distance. Using these two resources, we can make this search. We can make a vector search in the database. But we need to make additional steps to make the vector search. We need to generate the embeddings for the records. I have a table full of information. In my example, the table is a table of products from Walmart. So my table is full of products. I need to generate the embeddings for these records, the records which are already present in the table. Then, when the user makes a question, I need to generate the embeddings for the user question. I need to generate the embeddings for the user question. Then I have the embeddings for the user question, the vector for the user question, and the vector for each product. With these two, I can calculate the distance. We have the function vector distance. So I can calculate the distance. Then I can use the power of the queries in a database environment to get the closest records related to the user question. So the embedding generation is not a feature inside database. We need to access the feature of embedding generation outside the database. Then, once we make the search, maybe this is enough. We generate the embeddings for the record, generate the embeddings for a natural language question. Maybe this is enough for our solution. We can stop here. But if we would like, we can make even a further step. We can get the products that I find. I will find a lot of products related to the user question. I get the products that I find, and I can build a prompt for a large language model, and I can send this prompt to a large language model to actually build a natural language answer to the user. So the user will not only receive a quick answer, but a natural language answer. Then I execute the question in a natural language model and provide a natural language answer to the user. So I have the first two basic steps, and then I can decide if my solution stops on the first two or if I would like to go ahead and use a large language model to complete the solution. Then, to make all this possible, we have a very important new feature which is supported by the Fabric database. And remind that I mentioned feature parity between Fabric database and Azure SQL. Everything I'm demonstrating about Fabric database is also accepted in Azure SQL. It's because the feature is there as well. So this important feature is the SP invoke external REST endpoint. Who are developer here attending this session may already have noticed what this procedure is capable of. Yes, it's capable to make a call to an external API directly from T-SQL. From the SQL, you can call an external API and get the reply. Okay? This means for our solution that from the T-SQL, we can make the call from the OpenAI to the OpenAI service in Azure. And this means we can make the call to generate the embeddings. A step that I already mentioned is important, generate embedding. We'll generate the embeddings with an external call. And if we would like to submit the information to a large language model, we use the invoke external REST endpoint as well. We make an external call as well. So, external API calls from T-SQL. It requires a credential object. I need to pass an authentication. The Azure OpenAI service will not allow me to access it without an authentication. So I need to create a credential object to make the authentication with the external service. Can call Azure OpenAI service? Yes, we can make calls to Azure OpenAI service. Can call for embeddings or for GPT. I have two reasons to call in this sample solution that I'm talking about. But there is a security restriction that this feature can only call Azure URLs. Maybe some developers listening to this now are already disappointed because they were already thinking about calling their own APIs using this feature, but this only calls Azure URL. It's limited, right? Not really. It's only a security feature. Because if you want to call your own API, you can provision inside Azure an Azure API management service. And you host your APIs inside the API management service. And using this workaround, you can call outside URLs using an API management service inside Azure. This is a workaround to allow this procedure to make external calls, external API calls. But this is not our focus at the moment. I'm just mentioning that it's possible. So, creating the vector field. First step, I need to prepare the table Walmart product details and I need to create the vector field. So add product description, vector, vector 1536. So I'm creating a field of type vector and the size is 1536. Interesting, but what 1536 means? Well, we already talked about that SQL doesn't generate the vector, doesn't generate the embeddings. We need to make an external call to generate the embedding. What are we calling exactly? We are calling an embedding model inside Azure OpenAI. What model? We choose. We provision it there in Azure, but we choose what model we are using. And the point is, each different embedding model has a different vector size. So we need to know our embedding model and know the vector size for our embedding model so we can create a vector column. So the size depends on the embedding algorithm which is being used. Maximum field size 1998. We can't create anything beyond 1998. So we can see some algorithms and their vector sizes. And you can see, for example, I'm using this one, text embedding ADA002. But you can see there is a text embedding 3 that has a larger vector size. If I use this text embedding 3 algorithm, the vector will not fit the field. So this is already limiting, right? Not exactly. First, first point, when we make the call to the embedding model, we can send a parameter to the embedding model and ask the embedding model to return a specific size smaller than the usual that the model is capable to return. So we can still use the test embedding tree large, asking it to return this maximum size. So the embeddings will have this maximum size using this model. It's still limiting, right? Right. It's better than using an older model, but it's limiting. Yes, it's limiting. But in SQL Server 2025, which is already in release candidate version, this is already solved. The vector field in SQL Server 2025 already support uh, a bigger size. Then, after creating the field, we need to create the credentials. So create database scoped credential. The name of the credential itself can be anything. Usually we create the credential with the URL of our OpenAI service, but the name could be anything. Then the identity is a keyword. This is a keyword which identifies which type of credential this is. And this is a special credential of type HTTP endpoint headers. This is a new special type of credential which is used to gather the procedure to make an external API call. This credential used to gather that procedure will add to the header of the API call this key, which I'm including here. In this way, I can pass an external authentication to the API. Then, some tasks, such as create an embedding, will be made a lot of times. For example, I need to create the embedding for the existing products, yes. And then later, every time the user makes a question, I need to create the embedding for the question made by the user. So we need to create the embeddings a lot of time. I will not repeat this code every time. So we put this in a stop procedure. A stop procedure called get embedding. So this stop procedure is called get embedding. I create the name of course. And this stop procedure makes the call to invoke external REST endpoint. I'm making an external call. And I'm passing the parameter the URL. Where is the URL? How do I know the URL? The URL is dynamically built using a specific pattern for the URL for the OpenAI service. So I'm using the OpenAI service address plus OpenAI deployments. This is a fixed pattern. Then after that, I need to include the name of the model. This name of the model is generated when I provision the model in Azure. I need to know this name of the model. And this is fixed. I'm asking the model to generate embeddings for me. I'm asking to use one specific version of the API. And the deployment model created as a parameter to make this stop procedure flexible. This means that you can get the code of this stop procedure and implement it in your environment and use it for your own purpose because the deployment model name is flexible, is parameterized. Of course, you need to change the code of the procedure in relation to the OpenAI URL. This is a part fixed. Then, the payload. The payload is the content that we are sending to this stop procedure. What content I'm sending to this stop procedure here? The variable payload is defined here as a JSON object. See, the JSON functions. Maybe you read something about new JSON functions in Azure SQL and so on. Here is one place to use them. I need to create a JSON object where I have the value input and I need to define what I'm sending to create the embedding. And this input is the question, is the input that the procedure received. The procedure receives this input text. It can be either the question the user made, or it can be information related to the product to create an embedding for the product. The important is that this input will be sent to the Azure OpenAI to create the embedding. So the input test is on the parameter. Then, after we receive the reply, we need to extract the actual embedding from the reply. So I need to know exactly the format of the reply. Sometimes this involves some text and error. No one knows from the top of the head the exact embedding, the exact format of the reply. So sometimes this is test and error, and we are using another JSON function to extract the content and put in a variable. Initially, the variable is varchar max. Then, after extracting the content, we make a cast on the variable, which is a varchar max variable, cast it as a vector 1536, and then we pass it to the embedding variable. The embedding variable is defined as an output in this stop procedure. This will be the result of the stop procedure. That's it. So this is the first step procedure, get embeddings, to generate the embeddings for us. Then the next step, I need to generate the embeddings for all the products. Okay. In this case, I'm generating embeddings for a fixed number of products for 30,000 products, and I'm making a loop among the products. My loop among the products is making a select of the product. Luckily, in my database model, the IDs are sequential, so I will select the product with this exact ID according to this counter. So I'm selecting one product and I will use the product name concatenated with the product description to generate the embeddings. And then I call the get embedding store procedure. After selecting the product, I'm calling the get embedding store procedure. I send the name of my model. This is the name of my model in Azure OpenAI. And the procedure returns the vector. And then I update the vector in the database in the column that I created, product description vector. And I loop. I loop on this. Okay. Then build embeddings, then search products. Now is the actual result we are looking for. The result we are looking for is that I need to be capable to ask a natural language question. Help me plan a high school graduation party. Okay. Then I need to get the answer for that. What products are related to this natural language question? Okay. So first, we need to generate the embeddings for the question. Get embedding related to this question. And this brings me a vector. I have the search vector here. After I have the vector, I make a select. A select of the products, Walmart product details. And I'll make select calculating the vector distance. The vector distance, we use the method cosine to make the calculation. This is the most common method used, although there are some advanced variations related to this. Then I define the search vector. I want to know the distance between my question and the product. So I use my question and the field that I have with the vector for each product. And I have here the distance. And I ask to order by distance in ascending order. This means the first record will be the closest to my question. Then I make a put a top 10. Give me the top 10 products which are closest to the question. In this way, I know the products which most relate to the question. And in the same way, we see the effect of a top in this kind of search. There could be other products related to the question, but I'm intending to get only the top 10. In this example, I'm intending to get only the top 10 related to this question. So, search products with vector search. Let's see this example. Let's see this working. First, for the example, I will open the Azure portal. Let's see what's deployed there. So I'm using, in my example, in my scenario, I'm using this deployment of Azure OpenAI, this provisioning of Azure OpenAI. When I open it, I can use the Explore with Azure AI Foundry portal. And here we have what I need to look for, the deployment. Here in deployments is where we deploy the models that we can use. And here in deployments, I have one model called GeoLake. This is a GPT-3.5 model. And I have one model called text embedding, which is a test embedding ADA002. So one to generate embeddings and one to be used as a GPT model, as a large language model. I'll be using both in my example. So I have here the source code of each one of the files, each one of the examples that I explained. So the create of the vector field, create credentials, get embedding procedure, all these is here, but it's already executed. I already have these elements. So I can go directly to, sorry, this is the building embeddings for the products. This is already executed. I already have the embeddings for the products. And I can demonstrate that I already have the embeddings for the products. Let's make a select star from Walmart product details. No, not all. Let's get top 10 from Walmart product details, only for us to see the embeddings which already exist inside the table. So I'm seeing 10 different products, product name, description, and one of the columns I have is the product description vector, which has the generated embedding. I already executed the code to generate the embedding for my products. So I already have the generated embedding. Now, considering that I already have the embedding generated, I actually can make the question. Let's start with the question that I exemplified in this slide. Help me plan a high school graduation party. And I'll be generating the embedding for this question, and I'll make a select to show the result according to the vector distance. There it is. High school graduation party. Let's see the products that were returned. Um, grad party wall decorations is the closest one. Party creations, beverage napkins, prom high school dance, party creations, sweet baby grill, and so on. So I have results related to party and related to graduation that may be interested in a graduation party. Sometimes you get unrelated results as well. I asked for the top 10. This is an example for a graduation party. Let's change this quiz to plan a barbecue. Help me plan a barbecue at my home. So let me execute. Ah, I commented too much. So again, execute. Here. Now the question was to plan a barbecue at home. So we have uh, a meat smoker grill, charcoal grill, marinade sauce, McCormick grill, lime juice. So everything that close relates to a barbecue. That has a close relation to a barbecue. That's the idea. I'm not making only a text search. What I'm making here is a natural language search. I'm searching for the meaning, actual meaning of the information. Okay, let's move to the next step. The next is the optional step. I may would like to send my result to the large language model, send my result to a large language model, and get the answer from the large language model, questioning the GPT. It can be done in SQL or outside SQL. I may decide to not do it in SQL. I can just make the vector search in SQL and later call to the large language model to be done outside or not do it at all. We need to use the previous result. We got the result from the vector search and we need this result for a large language model call. Then it will make an additional analysis of the product list and provide us the result with a better explanation about which products fit the purpose and why those products fit the purpose. That's what the GPT will provide. So we need to convert the product list to JSON. A part of the query that we need to build is a conversion of the product list to JSON. The query that I was using to return the product list will need to include some more JSON functions to convert the list of products to a JSON format. First create a JSON object, then transforming the JSON object in an array. These are new functions recently released in Azure SQL. Then I build the prompt. I build the prompt with the function JSON object, and inside the prompt I pass. I use the function JSON object again and JSON array to pass the JSON products together my content. And I also, in another object, I pass the question that the user made. For example, help me organize a barbecue at home. This is the question that will be passed together. We'll have a JSON array with the prompt, with the products, and the question of the user. JSON array. Then we make the GPT call with SP invoke external REST endpoint. Similar as before, the address is built in a different way. We need to pass the credential as well. We are passing the credential, the payload. We get the response, and then we need to translate the response using OpenJSON functions. As I said before, no one remembers this format from the top of their head, so it is a bit of trial and error to find the correct format, especially because the format can be changed according to the instructions you sent. So it's a trial and error to find the correct format. Then we transform this into a store procedure to make a question and get the answer from the LLM model, the large language model. Let's see this working. So again, I'm using the same initial question, help me plan a high school graduation party, and I call a procedure called get answer. Inside this procedure, there is a call to generate the embeddings for this question. There is a search to find the products closest related to this question, and then a second call to the large language model to get the answer. Then I execute. All these calls that I explained were already executed and provided me this result after my translation of the result from JSON provided me this result. I asked the result to have this specific format. Let me copy this result to the notepad, and you can notice the result is explaining which products you need for what, for decorating, to create a festive atmosphere, and so on. And I asked the model to provide a list of the products selected in a separated field and to provide a reasoning why these products were selected, why these products are being suggested to the user. So the model explains why these products were selected to the user. And I can try with something different. I can change this question and try this. Then um, barbecue at home. Mind that my query originally had a top 10, but the large language model decided that only two products were relevant for the first question, were high relevant for the first question. And let's see this second question. It's bringing me only one product, true. Um, then let's analyze the reasoning. It could bring more products, could. Sometimes it depends on the model itself. Sometimes the model takes a decision that we don't like. We may need to improve the instructions. So it's explaining what the user would like to have, would like to buy to have a barbecue at home. In this way, we are building AI solutions in a SQL environment, in a Fabric database SQL environment. And we have lots of possibilities in the middle, what I exemplified. We can use the vector search for numerous possibilities, or we can build the entire solution calling the large language model with the result of the vector search and providing the result in a natural language form, as this last example. Some reference. The files for this presentation can be located in this link. There is a Wikipedia walkthrough, a walkthrough with a Wikipedia demo. There is a Walmart walkthrough, I believe the Walmart walkthrough is not so precise. You may need to adapt from detail, but you have my source code as well available. Thank you everyone for attending this session. I hope everyone liked it. And any questions?
While everyone is putting their questions into the chat, because I know everybody had some great questions, as this has been very informative. I know I'm going to start using the heck out of this sucker, which may cost us a lot of money, but hey, we'll figure
Good.
it out. Do want to remind everyone while they're actually thinking of the questions they want to ask. Uh, next, let's see, our next presentation for DBA fundamentals is going to be in February. Navigating the Cloud, a glimpse into Microsoft Fabric administration with Warwick Rudd. Be sure to come to that because that was going to be a lot of fun for everybody that's learning and trying to use a lot of stuff with Fabric these days. And it shows the actual administration side of it, which a lot of presentations don't do these days. Be sure to come to us for that one. All right, so Stephen has a question. Do you have a preferred source for IntelliSense or function documentation for the newest Azure SQL vector embedding features?
Um, um, Two things. IntelliSense is one, function documentation other. Function documentation I use Learn. I use Learn for future document feature for function documentation. It's detailed, yes, it's detailed. But when you get deeper in relation to the functions, you are involving a lot of the mathematics related to the vector. Sometimes it's hard to understand all the mathematics related to this without an actual presentation. The only presentation that I'm aware about it was private. It's not public. I wrote an article about this. I published a blog on Simple Talk about advanced vector search features in SQL database. It's on Simple Talk, but the link was not included there. About intelligence, I don't have a precise source for that. But what I can say as a suggestion where to look is that the newest versions of SSMS were released way after the vector feature was available in Azure SQL and Fabric database. So my guess is the newest version of SSMS may be supporting intelligence for the vector features and vector function. I would try that.
Yeah, that's a good point. Remember, everything with Fabric these days is definitely on the move and can update within minutes. As me and Dennis were talking about prior to this meeting, we've been on and seen changes go live and we weren't aware of them. As a few friends of mine have had over the years, we've been about to give a presentation and lo and behold, you go into Azure Portal or any of the wonderful tools we use these days and you see new things. You're like, oh, new things, new fun. Um, yeah, but like Dennis said, the documentation is great. You really have to get into it, and they are updating the documentation all the time. And I literally mean all the time. I believe some of this documentation is actually available on GitHub, so you can document it yourself when you figure out new things. Um, Always good to learn. I'll turn it back over to you, Dennis, for any more thoughts you had on that one.
Yes, that's a fact. The documentation is available on GitHub for additional contributions, right? So anyone who would like to study this deeper and add to the documentation, probably this will be very welcome. Um, Also, thank you, Mara. Glad that you like the explanation. Thank you very much, Mara. And yes, the newest SSMS is the 22, the 22.
Right. That gives out lots of the new features, especially the connection to the fabric, which is really nice. Actually, I'm going to start using that this afternoon, so this is going to be fun.
Great. Thank you very much. It was a pleasure to deliver the session.
Glad you could make it, Dennis. Yeah, thank you so much. As with that, thanks everyone for coming. We will see y'all very soon. Thanks, y'all. Have a great
See you
day.
soon. Bye.
Begins.
Bye.